Trigonometry, Unit 4, Vocabulary. Initial side, the beginning ray of an angle. It represents the fixed ray. So as you can see here, here's the initial side in this first picture. The second picture for the positive angle, initial side is here. And for the negative angle, the initial side is at the top. Basically the dark black lines here are the initial sides. Terminal side, the ending ray of an angle after it is rotated about the vertex. So as you can see here, this is labeled the terminal side in this picture. In this one here, the terminal side is this blue line. In this picture here, the terminal side is the red segment. Positive angle, the angle generated by a counterclockwise direction, called a positive angle. Counterclockwise direction. So this angle is opening up this way, that's a counterclockwise direction. Counterclockwise goes like this, like the hands on a clock. Clockwise goes like this, and hands on the clock go like this. So there's a counterclockwise direction, that is a positive angle. Here it shows you here also, it opens up this way, counterclockwise direction, positive angle. Here this one opens up this direction, that's clockwise, that's a negative angle when it goes clockwise. So negative angle, the angle generated by a clockwise direction. A positive angle is the angle generated by a counterclockwise direction. Standard position, an angle positioned on a graph with its vertex at the origin and its initial side along the positive x-axis. So this is an angle in standard position because it has your initial side here on the x-axis and the terminal side is someplace else. So it's not on the x-axis, it's over here in this case. That's called standard position. Again, an angle positioned on the graph with its vertex at the origin. So vertex is right here at the origin. That's called the vertex of the angle where my red dot is. And its initial side along the positive x-axis. That's called standard position. A quadrantal angle is an angle in standard position whose terminal side lies on one of the axes. So this is a quadrantal angle right here because the initial side is here along the x-axis. The terminal side, this red ray here, is along the y-axis. Now another quadrantal angle would be if you had a line or a ray going this direction along the left side of the x-axis. Another quadrantal angle would be if you had a red line or ray going down here on this part of the y-axis down below. So those are called quadrantal angles because, as it says there, a terminal side lies on one of the axes. Next, degrees. The measures of angles that is 1/360th of a complete rotation in the positive direction. That's called degrees, the measure of an angle in terms of degrees. The reason it's 1/360th is because that's how many degrees there are in a circle, 360 degrees in a circle. So 1 degree would be 1/360th of that, which would be 1 degree in that, in other words. Radians, another way of measuring the measure of angles. It says the measure of central angles whose sides intercept arcs that are the same length as the radius of the circle. Minutes are units of angle measures that are 1/60th of a degree. The reason the 1/60th is there, think of it in terms of like minutes related to hours. 1 minute is 1/60th of an hour. So minutes, unit of an angle measure that is 1/60th of a degree. Seconds, units of angle measures that are 1/60th of a minute. Well, I hope we can understand that pretty easily because that's how seconds are related to minutes. Each second is 1/60th of a minute. And each minute is 1/60th of an hour, so each minute in terms of angles and circles and degrees and stuff, each minute is 1/60th of a degree. These are all measurements for angles involving circles. Okay, next, unit circle is a circle of radius 1 unit whose center is at the origin of a graph. So these are two pictures of unit circles. This is a unit circle that also has the degrees laid out for you, starting at 0 here on the x-axis, going all the way here to 90 degrees up here at the top. Keep on going all the way to 180 degrees here on the left. Keep on going to 270 degrees here at the bottom, and keeping on going to 360 degrees. Over here it's 350. Next will be 360. So 0 and 360 are basically the same mark here on this unit circle. These are called unit circles. If the radius is one unit, then these will be unit circles. Next, degree and radian conversion formulas. So 1 radian is equal to 180 over pi degrees, or about 57.3 degrees. The reason 57.3 degrees is there is because pi is approximately 3.1, whatever you wanted to say. You go on and on forever, so many different digits. So since pi approximately 3.14159 and so on, that's what pi is, 3.14159, and numbers keep on going. If you take 180 divided by 3.14, you get about 57.3 degrees. And then 1 degree is equal to pi over 180 radians, or about 0.017 radians. That number is oftentimes read 17 thousandths. So if you take pi over 180, it's equivalent to about 17 thousandths radians. Again, take pi, which is 3.14159, divided by 180, you get approximately 0.017, or 17 thousandths radians. Once again, these are conversion formulas you can use. Sometimes you have to convert radians to degrees, sometimes you have to convert degrees into radians. So these conversion formulas will help you out with that. Next, coterminal angles are two angles in standard position that have the same initial side and the same terminal side but have different measures. You might ask, well, how is that possible? I'll explain that in a moment. Next, reference angle says the acute angle formed by the terminal side of an angle in standard position and the x-axis. Okay, so looking at these pictures right here, and a couple more things here, one time real quick, symbols. This symbol represents theta, that's how you pronounce it. It's a Greek letter of the alphabet representing theta. Sometimes in terms of angle measurements, you might say solve for theta. This looks like an A, means alpha, and this thing looks like a capital B sort of. It's called beta. Again, these are Greek words that mean different things involving, in this case, involving measures of angles. They might use these interchangeably. So be aware of that these represent Greek words that represent angle measurements. Now going on to these pictures right here. So we have some coterminal angles in these pictures. Both pictures are showing the concept of coterminal angles. So this angle here has a measure of 45 degrees. This angle also has a measure. If you start here, you go there, that's 45 degrees. And then it keeps on going all around like this. Eventually it comes back around again. So it gives you 405 degrees. So 45 degrees and 405 degrees are said to be coterminal angles. They have the same initial side, the same terminal side, but they have different degree measurements. If you go this other direction here, you get negative 315 degrees going this way. Now, I'm going to save how do you figure these numbers out for another time. Maybe a teacher might go over these instructions about how you know how to find coterminal angles. As another lesson, today's lesson, the focus is just to help you understand the vocabulary. Maybe someone else might explain why that is later on. And over here, notice you have this angle measurement is a degree of alpha. We start here. Remember, these are coterminal angles because they have the same initial side and the same terminal side, but this is an alpha measurement. And if you start here and go around this way, that would be alpha again, same thing. We keep on going all the way around, one complete revolution here, ends up over here. That would be representing a different angle measurement, which would in this case represent beta. So there's your alpha and there's your beta, two different measurements for the same angle called coterminal angles. Okay, I didn't put anyone here involving theta, but hopefully that helps you at least get it a little bit. Since this might be a theta in here, and maybe you could have an alpha, and then you might have another one, it might be a beta. There could be three different coterminal angles and so on like that. So that's basically the concept of coterminal angles and the concept of understanding these symbols and what they mean, or what they indicate. Next, definition of sine and cosine. If the terminal side of an angle theta in standard position intersects the unit circle at a point P located at x, y, then cosine of theta is equal to x, and sine of theta is equal to y. That's if your radius is going to be a 1, then you basically would have cosine of theta equal x and sine of theta be y. More on that in a moment. Probably, I think on the next slide you'll see that information about something like that again. Next we have trigonometric functions. You have the word, complete word there. It says sine. Sine represents the function y equals, there's an abbreviation for sine, sine of x. And also put in there so you remember sine is abbreviated sin. It's pronounced sin, but it's never sin, it's always sine. It's just an abbreviation for the word sine. Cosine, the function y equals cosine of x. That's how you abbreviate cosine. As it says over there, it is abbreviated, it looks like cos, cos, but it's not pronounced cos, it's pronounced cosine. There's an abbreviation for it. And tangent, the function y equals tangent of x. It is abbreviated, it looks like the word tan. Instead of saying tan, if we see that abbreviation, we say tangent. Next is cotangent, the function y equals cotangent of x. It is abbreviated with the COT, which could be pronounced cot, but it's not pronounced cot. It's abbreviation for cotangent, so we say cotangent when you see that. Next, secant is the function y equals secant of x. Looks like we have sec for short for second. And we don't say sec for second, it is abbreviated SEC for secant. And last we have their cosecant, the function y equals CSC of x, it is abbreviated CSC. And there's no really way of pronouncing that one, cosec or whatever, I guess, but so it's kind of weird to say it that way. But when you see those three letters like that involving trig functions, you'd say cosecant. So that's more terminology there you'd have to understand for lessons involving trigonometric functions. So next is we have trigonometric functions in a right triangle. For an acute angle A in right triangle ABC, the trigonometric functions are as follows. Sine of A is equal to opposite or hypotenuse, or sometimes we say lowercase a over lowercase c. Cosine of A is equal to adjacent or hypotenuse, which is lowercase b over lowercase c. Tangent of A is equal to opposite over adjacent, which is lowercase a over lowercase b. Cosecant of A is equal to hypotenuse over opposite, which is lowercase c over lowercase a. Secant of A is equal to hypotenuse over adjacent, lowercase c over lowercase b. Cotangent of A is equal to adjacent over opposite, which is lowercase b over lowercase a. Now, where did all this stuff come from? Where's those lowercase a's, b's, and c's coming from? They basically come from Pythagorean's theorem. You might remember Pythagorean's theorem from geometry and algebra 2. Pythagorean theorem, normally the lowercase c represents hypotenuse. That's why if you look here, all the places where there's a hypotenuse, there's a lowercase c where the hypotenuse is. Every time we have a hypotenuse there, across from it is lowercase c, every time, because c represents hypotenuse in a right triangle from Pythagorean's theorem. And basically, if you're dealing with capital A, normally the side opposite of capital A would be lowercase a. So that's why when you have the word opposites, there's a lowercase a across from it. Every time there's an opposite, there's a lowercase a across from it. Each time, opposite, lowercase a. Opposite, lowercase a. They kind of go together. And so since c is hypotenuse and the a is the opposite side, that means that the b would have to be the adjacent side. So notice every time there's an adjacent, here's adjacent, there's a lowercase b across from it. Here it says adjacent, lowercase b. Adjacent represents lowercase b, and again adjacent represents lowercase b. It all comes from right triangles and Pythagorean's theorem. These all kind of go together. So to help you remember the main three trigonometric functions, the main three are sine, cosine, and tangent. All three of these over here on the left side are the most important three trigonometric functions. You use them a lot in geometry. You don't even use these other three in geometry. But I think in trig, I know you use these three, probably these three also. You probably learn these in trig, in algebra 2. In trig you use all 6 of them, of course. That's why I'm teaching you guys these right now. So in geometry it's only these 3. I believe in algebra 2 it's all 6 of them, and in trig especially all 6 of them again. So how can you remember the 3 main trigonometric functions? Sine, cosine, and tangent. It's this way right here. It's called SOHCAHTOA. What does this mean? Well, the S stands for sine. Sine is, O stands for opposite, H stands for hypotenuse. So the sine is opposite over hypotenuse. There it is. Sine is opposite over hypotenuse. C stands for cosine. The A stands for adjacent. Remember, H stands for hypotenuse. So this means cosine is what? Adjacent over hypotenuse. Look at cosine. Cosine of A is adjacent over hypotenuse. There it is. And finally, the T here represents tangent. O again stands for opposite. A again stands for adjacent. So the tangent is the opposite over adjacent. Here it is. Tangent is opposite over adjacent. There it is. So this SOHCAHTOA is kind of a device that you can use to help you remember these three main trig functions. Okay. So now next, kind of piggybacking on that, we have your circular functions, or functions defined using a unit circle. Trigonometric functions says for any angle with measure theta, a point located at xy, point P located at xy on its terminal side, and r equaling square root of x squared plus y squared, the trigonometric functions of theta are as follows. Now keep in mind here, this comes from the Pythagorean theorem. X squared plus y squared equals r squared. Or if you switch it around, you get r squared equals x squared plus y squared. And then when you take the square root of r squared, basically the square root cancel out, leaving you r. Take the square root of x squared plus y squared, you get this. So again, this is relatable to Pythagorean theorem. That's basically where it comes from. This formula here, you see here, comes from Pythagorean theorem, where r represents the hypotenuse. X represents the A, y represents the B. So x squared plus y squared equals r squared. Switch it around, r squared equals x squared plus y squared. Take the square root of r squared and you get this expression right here. So r being the hypotenuse r would go on wherever the hypotenuse is located in your trigonometric functions you saw on the previous slide. So in that case, sine of theta would equal to opposite over hypotenuse. The opposite would be the y side here, as you can see in this picture over here. Opposite of the alpha, sometimes referred to as theta in some cases. Opposite side of the alpha would be the y side, so y goes on top. Hypotenuse is the r side, r goes on the bottom. Hypotenuse on the bottom. Remember from the previous slide. Here's a right triangle here illustrating these concepts. Cosine is the adjacent hypotenuse. Which is the adjacent side here? If you take an alpha, the adjacent side would be this side right here, which is labeled as the x. X, the adjacent side, adjacent goes on top because cosine is adjacent over hypotenuse. Hypotenuse r goes on the bottom. How about tangent of theta? Well, tangent represents opposite over adjacent. Remember from the previous slide, it's opposite over adjacent. In regards to the alpha here, what's the opposite side? Y. What's the adjacent side? X. Opposite y goes on top, adjacent side x goes on the bottom. And notice the next ones here are basically these other expressions just basically flipped, or we call it reciprocal in math. Cosecant is the reciprocal of sine. Take the sine and flip it. Y over r becomes r over y. Secant with theta is the reciprocal of cosine. Take the cosine ratio and flip it. X over r becomes r over x. Cotangent is the reciprocal of tangent. So take the fraction representing tangent, y over x, and flip it. You get x over y. So that's what you have here. Now, this makes sense. Tangent and cotangent, they sound very similar. They're related. They are reciprocals of each other. Over here, this is kind of odd that you have sine and cosecant are reciprocals. Cosecant sounds more like it should be paired with cosine. And secant starts with an S, like sine starts with S. Seems like secant should be reciprocal of sine, but that's not how it is. The cosecant is reciprocal of the sine, secant is reciprocal of cosine. To help you remember that, think in terms of opposite. Tangent, cotangent, easy, they sound similar, they go together, they're reciprocals of each other. But when it gets to sine and cosine, think opposite of this. Sine and cosecant are reciprocals of each other, and cosine and secant are reciprocals of each other. Okay, so here we go. Here's the illustrations involving these concepts. Here's your theta. Opposite would be this one going up and down, which would be the y segment. The adjacent would be this one, this side here going across this way would be the adjacent segment, the x piece, the x segment, and the radius is 1. So when the radius is 1, that's why on our previous slide you saw sine of theta equals y. Because if the radius is 1, you put a 1 here in place of r, you get y over 1. And what's y over 1? It is y. So when the radius is 1, sine of theta is equal to exactly y. When the radius is 1, you put a 1 in place of r right there. You got x over 1. And what is x over 1? It is x. So cosine of theta would equal x when the radius is a 1. That's why I saw on a previous slide sine of theta equals y, cosine of theta equals x, because of this concept right here. So I make sure I illustrated that concept as to why that is. Now I didn't just tell you what it is, now you know why it is, because of these ratios. So I hope these pictures and explanations help you in your journey through trigonometry. And maybe in algebra 2 as well, because you see some of the stuff in algebra 2 also. Next says solve a right triangle. What does that mean? You see this expression in instructions that says solve the right triangle or solve a right triangle. How do you go about doing that? This is how you do it. To find one or more unknown sides or angles of a right triangle. That's what the instructions mean when it says that. Now in order to solve a right triangle, there's going to be some information you have to be given. There are 6 parts to every triangle, 3 angles and 3 sides. You have to be given at least half of those things in order to find the other pieces. Sometimes you probably can do with just 2 of those things, because then there's other things you can do. There's formulas you can apply. You give at least 2 things, either 1 angle on one side, or 2 angles on one side, or whatever. All 3 angles, all 3 sides, or whatever. But you're given all 3 sides, you can find the 3 angles. Given 3 angles, you can find all 3 sides using some trig functions. 2 angles on one side, 2 sides on one angle, whatever the case may be. You can always find the missing pieces by using trig functions and trig formulas. Again, that'll be on a previous lesson. Today's focus is, or the focus of this lesson is mostly on vocabulary and understanding instructions. Next, angle of elevation. What does elevation mean? It means going up, basically. Elevate. Like the word elevation comes from a word some of you might hear in sports. Man, look at that person elevate. You might hear that when they talk about a football player, like a wide receiver, jumping up real high to catch a ball that was thrown way high and it's over the person's head, but the wide receiver jumps up and catches it. Look at that person elevate. In basketball, when a person jumps up to dunk the ball, look at that person elevate. Elevation means up. So angle of elevation means it's the angle that's going upward. And that's basically what it says. It says the angle between a horizontal line and a line of sight from the observer to an object at a higher level. How about angle of depression? Depression is kind of like down. Someone that's feeling kind of depressed or sad means they're kind of feeling down. So that's what angle of depression is. It's down basically. So the definition of angle of depression is as follows. The angle between a horizontal line and line of sight from the observer to an object at a lower level, angle of depression. So I included some pictures here to help you understand these concepts. So here we have angle of elevation right here. Notice, as it says here, an angle that is between a horizontal line. Horizontal line goes across like this. For those that might have a hard time understanding horizontal line, it comes from an expression. When you look out over the horizon, when you look out over the horizon, like you're standing on a coast, on the ocean, you're standing on the beach or whatever, you look out over the horizon, looking out across the ocean, looking out over the horizon, looking straight ahead. Horizon, horizontal line, straight across, left and right. So here it is, horizontal line, and then this person, here's the observer, looking across this way, horizontal line, to all of a sudden then looking up, sight line here is looking up at an object. Could be a person looking up at a bird or a plane or something else that's in the sky, a balloon or whatever, a hot air balloon. Angle of elevation is looking up at something. Okay, angle of elevation. Angle of depression is, here's the observer looking straight across. The observer is now looking down. Maybe it's standing on a pier or something and looking into the ocean at a seal or a shark or a whale swimming by or whatever, or staying on a mountain looking down at maybe a house or something that's down below the mountain, or whatever the case may be. Observer looking over the horizon straight out to all of a sudden looking down. Keeping the eyes looking straight ahead like this, to all of a sudden turning the head and the eyes are looking down. Angle, here's the sight line right here, so you're looking down, That's called an angle of depression. If I put them all together in one picture here, here's a person looking out over the horizon here. All of a sudden decides to look up at the airplane. Angle of elevation. There's a person looking out over the horizon. All of a sudden looks down at a dog that appears to be shorter than this person is, or kind of the person standing on a hill. The dog is standing kind of like at a lower level of the mound or whatever, standing on a mound looking down at the dog. So that's called angle of depression, looking down. There's looking on the horizon, all of a sudden turning your head and the eyes to looking down. Angle of depression looking down, angle of elevation looking up. Hope these pictures help you understand the concepts of angle of elevation and angle of depression.